All right, so we got ourselves another topic, distance and displacement. So boiled down, if you were to take this in a pot, put it in there, you boil it down, what you would find is you would have two simple definitions here. Distance. Distance, as you can probably estimate, is going to be just how far you are going, okay? Another way to put that is path length. Okay, so for instance, let's say we had a starting point right there, ending point right there, and we just wanted to make a path. Okay, so let's start off right about here. Let's make a 2 centimeter long path. Cool. So that's 2 centimeters. And we find ourselves going downward, going down about 4 of them centimeters. Sure, it doesn't matter. Then after that, we're going to go, might as well, let's not go left. Let's go right. You go right 5 of them centimeters. Okay, there you go. And then finally, well, not finally, we're going to do 2 more little junctions here. We're going to go down 2. Oh goodness, I haven't been labeling these. 2 centimeters. This was 5. I think. Let me double check that. Yeah, cool. And then that one was 4. Okay. I'm sorry. I'm so bad at this. Oh goodness. And that's about 1. Right? Just about 1. That looks about right. Yeah. Just about 1 centimeter right there. Okay, so we find ourselves with a path right here. One that goes right, then down, then right, then down, then right. And if we were to find the distance, all we'd have to do is add up all of those paths. Oftentimes I will abbreviate distance as DIST. All I have to do is add them. 2 times 5, oh, not 2 times, 2 plus 5, 4. I know how to count is 6. 6 and 5 is 11. 11 and 2 is 13. And 13 and 1 is 14. Okay? So our total distance traveled should be 14 of them centimeters. Okay? Simple as that. You just add up the pieces. 2 and 4 and 5 and 2 and 1. 14. Now, displacement's a little different. Displacement, what it is it's a straight line path length between the start and end point. So right here, we'll go back over to our little drawing. We start here, we end here. Okay? So we need to make a straight line path length between the two. Okay? So here we go. We got our starting point, our end point. We make a line going like that. So if we were to define displacement, it would be the length of this line. And you'll notice I have width with a bunch of underlines next to it, direction. Okay? Now the direction's important because it tells us what's actually happening. Distance, all of that tells you is how long your path is. So for instance, you say you went to Lafayette, well that path is about, I don't know, what, 30 miles, 40 miles, something like that, right? But the displacement's going to be different. If you're able to drive through the fields and drive through the houses, which you shouldn't do, by the way, if you were able to do that, it would be a shorter distance, okay? It wouldn't be the same distance. And then you could say, I went to the west a certain distance if you went to Lafayette there. Now, so what we got to do next is we've got to measure the path length. Oh, goodness, this ruler. Okay, so let's measure it in centimeters here. It looks like we've got just about 10, we'll call it 10. So our displacement is just about 10 centimeters, and we can say down and to the right if you like. And right, we don't need to know angles at present. That is perfectly fine like that, down and to the right. So we've got a distance and we've got a displacement. The displacement is the straight line. They oftentimes say as the crow flies, okay? So a thing that doesn't care about barriers, doesn't care about obstacles, just goes straight to the end, okay? And we can see that it's going down and to the right. And so one thing that we can do to denote which way it's going is by adding a little arrow on the end of it, okay? So it's going down and to the right. Now, you'll notice once again that displacement is a shorter distance than the total path length distance, okay? This will always be the case. This should be always shorter than this, unless, of course, your path is a straight path. Then they'll be equal. Okay? So, another way that we can look at these distances and displacements is not necessarily just going and measuring directly. What we can do is we can add and subtract them based on some simple rules, okay? So let's say that we have a displacement. We start off right here. We have a first displacement. We go 1, 2, 3, 4 centimeters this way, okay? Then the next thing we do is we travel backwards 2 centimeters, okay? So we have a second one, and I'll write it below, just so it's a little easier to recognize. Okay, 1, 2, back. So this is what we did. We went along a path, and then we came back along that path, okay? And before we said this is 4 centimeters to the right. This is 2 centimeters to the left. So to find the total distance traveled, all we have to do is add the two pieces. We got 4 and 2, that's 6 centimeters. To find the displacement, we go from beginning point right there to end point, which is along this point right there. Okay? Now an easy way to do this is think of arrows going to the right as being positive and arrows going to the left as being negative. So in this case it would be positive 4, and then you add up a negative 2, and then that gives you just a total displacement of 2 centimeters. And is this positive or negative? If it's positive, it's going to the right. If it's negative, it's going to the left. In this case, it is indeed positive. Okay, so just to verify that we understand what's going on, let's do another one. We're going to do 3 of those centimeters. We're going to go 1, 2, 3, right there, centimeters in this direction to the right. We're going to go another 2. Let's make sure I lined it up here. Another 2 centimeters. Oh gosh, line it up, me. Okay, another 2 centimeters. 1, 2 to the right. And then we will take a step back. How far do we want to go back? I don't know. 1, 2, 3, 4. Why don't we go back 4? We'll start. Make sure we're right there. Okay, 1, 2, 3, 4. There it is. Find ourselves going back 4 centimeters. Okay, so total distance. We're going to do distance and displacement again. Distance. Make sure it's up in frame. Stay in frame. Stay in frame. Okay, 3 plus 2 plus 4. So 5 and 4 is 9 centimeters. All right, now displacement. We got to do that arrow stuff again. All right, so 3 is going to the right, so that will be a positive 3. 2 is going to the right, so that will be a positive 2. And then we've got 4 to the left, so that will be a negative 4. We add all those up. 3 plus 2, 5, minus 4 gives us but 1 centimeter. Is that positive or negative? Well, looks like it's positive. So that means we've got a displacement of 1 centimeter to the right, because right is positive. All right? Now, we can apply this then. I'm going to flip over the paper here in just a moment. We can apply this then to multiple directions, because why not? Because we don't always travel in a straight line, right? So let's apply it to multiple directions real quick. See, it was a seamless transition. Actually, hold on. Okay. So here we go. Why don't we do the same thing again? We will find ourselves a new path that goes differently. Okay, so why don't we go, oh, it doesn't matter. We'll start right here. Let's do 9. Sure. Okay, we're going to go 9 to the right. Okay, and then we're going to go, what is it, 12, I think? No, wait, hold on. 3, 9, 4, 12, yeah. I know it doesn't seem important, and it probably isn't, but I want to make sure that I do it right. See if we can't get a real answer here. Okay, 12 now. There we go, cool. Now, you might be saying to yourself, this doesn't look the same. This is not doing the same thing it was doing a moment ago. You're right, it isn't. This one is going to be different. This is going to be like our first example that we did here a few moments ago. And the difference here is that the displacement goes from beginning point to end point, and it just so happens this isn't in 1 dimension like it was before. This is in 2 dimensions. So our displacement will go from beginning point to end point, and then we draw our little arrow. That's the direction we traveled. Okay? Now, me drawing that little tiny itty-bitty square in the corner should probably clue you in as to what's next. All right, next step, of course, is to do something that isn't just addition or subtraction like we were doing with those straight line guys over here. Not with these guys. We're not in a straight line anymore. So what we're going to have to do instead is probably find out some triangular stuff, right? Triangle stuff is always fun. We do this by using the Pythagorean Gosh dang, about misspelled it. Probably still did. Pythagorean Theorem. You guys remember this one? This is the legs of a right triangle. A squared plus B squared equals C squared. So let's define our A and our B. Here's A. Here's B. And then C is our unknown. Oh goodness. Whatever could it be? So now we plug in our numbers. 9 squared plus 12 squared equals C squared. 9, as the Germans say no, is 81 when it is squared. 12 squared is 144. And that should equal C squared. Now, to make sure we do this right and make sure that you believe me, oh no, Pokemans go. We see here, right here, my friends, that we've got 81 plus 144. That gives us 225. All right, if you guys have remembered your squares, you'll know the answer immediately. But if you don't remember your squares, that's fine too. It doesn't matter. We've got a calculator to do it for us. All right, take the square root of both sides, and we find that C is equal to 15 centimeters. So that means if we were to go over here, C equals 15 centimeters. Let's go ahead and erase that, plug in 15 centimeters. And we know that it is going down and right. If you wanted to do it like a compass, where north is that way, south is this way, east is this way, and west is that way, you could say it's going to the southeast, right? Because it's going down and to the right, southeast. But if you want to say down and to the right, that also works. Okay, so it's not too terrible. All you got to do is use the things that you've used in the past, like the Pythagorean Theorem. And you need to think about how things work in terms of their directions. Okay, so down here we see the path length is always going to be the same there. The distance is 6, but the displacement depends on whether you're going left or right. Okay, I guess we didn't do, this is the displacement right here, right? Well, we need to do distance probably too. Distance is the path length, so 9 and 12, which should be 21 centimeters. Okay, but I didn't get that skipped. So yeah, there you have it. There it is. Our displacement, 15 centimeters. Our distance, 21.